Good afternoon, everybody. I'm Shailaja Suresh, a Senior Solutions Architect with AWS. And I'm here today to touch on two broad topics. The role that Amazon plays towards sustainability and how do you get to reduce carbon footprint by migrating your workloads to AWS. That said, let's dive right in. And here's the agenda. So we would need to know what the climate pledge is and what sustainability is, which is the first topic. And Amazon is huge. There are lots of things that we could touch on under the topic of sustainability. So we would focus specifically on two things today here, renewable energy and transportation and delivery, since I believe they would add a lot of value to this specific audience. We would then dive deep into sustainability in the cloud, followed by the ASDI initiative, along with infrastructure optimization topics. Okay, let's start with a climate pledge. Before that, we need to know what the Paris Agreement is. So the goal of the Paris Agreement is to strengthen the global response to climate crisis by 2050. In 2019, Amazon and Global Optimism made a commitment to meet the Paris Agreement 10 years early. And this commitment is called the Climate Pledge. The goal as part of this commitment is to have zero net carbon in Amazon operations by 2040. So once again, we are huge, and how do we track our emissions? This is why we built a carbon system of record. So we began by tracking our impact in terms of carbon emissions in our shipments, data centers, and in our devices. And once we figured out the hotspots, we did monitor and reduce the emissions over time. We again thought flywheel here, which is typical in Amazon, for this model to work, and where renewable energy helps in clean manufacturing, which leads to better fulfillment and delivery. All right, so moving on, what do we exactly measure? So there are 5 models that we use as a template to track emissions. First one is the financial model. The financial model helps us to see the big picture and only prioritize on those items that really provide value to our customers. The second one is under transportation, where we not only track the emissions of our delivery trucks, but also the emissions that happen while shipping products to and from our warehouses. Third is the electricity that we consume in our data centers, offices, and warehouses. The fourth is packaging, as to how we could reduce the boxes used and how efficiently the products could be accommodated together. And the fifth is our devices, where we track the manufacturing, the use, and the end life cycle phases to gauge the carbon footprint. Okay, moving on to sustainability. So what is sustainability? Sustainability, in a nutshell, is the balance between the environment, equity, and economy. Sustainability touches many areas of our economy, from how we decarbonize our business operations to water conservation and even to responsible employment. In this presentation, let's focus on environmental sustainability and initiatives that address the climate change and decarbonization. That said, let's move on to the topic of renewable energy. Let's see how Amazon brings about sustainability transformation with the use of renewable energy. Okay, so Amazon sustainability efforts are happening all around the globe, and we have our largest wind farm in rural Texas. And talking about our solar projects, this March we announced our first renewable energy project at Singapore. It has a series of solar panels mounted on a ground system. And a benefit of ground-mounted solar panels is that its ability to optimally position itself as the weather conditions change. So this project is expected to generate clean energy, which is enough to power more than 10,000 homes at Singapore annually, which is pretty impressive. In 2020, we became the world's largest corporate purchaser of renewable energy. Let's shift gears and focus on transportation. Transportation sustainability is a big deal to us, especially with the shipments for our products. And here is an interesting example. I'm sure you like this. Our scientists developed a model to compare the carbon intensity of ordering Whole Foods Market groceries online versus driving to the nearest Whole Foods Market store. The study found that online grocery deliveries generate 43% lower carbon emissions per item compared to shopping in store. That's interesting and a very valuable piece of info, isn't it? All right, so let's move on to micromobility. In 2019, before micromobility, I do want to touch on the Rivian part, which is on the left-hand side. So in 2019, we ordered close to 100,000 custom electric delivery vehicles from Rivian. And you might have actually seen some of these vehicles on the roads now. And along the same lines of delivering products, there is a picture on the right-hand side, which most of you might have not seen. I mean, it's pretty new to many of us here. So in dense urban centers like New York City, Paris and Tokyo, we deliver packages by bicycle on foot using push walkers. And that's what this micromobility initiative is all about. And let's double click further on transportation. We are developing autonomous delivery powered by clean electricity. Innovations like Amazon Scout and Primad drones, which you see in those pictures, are autonomous devices that can deliver packages. And these devices are currently being tested to be able to transport small packages quickly and safely. Let's move on to Shipment Zero, which is my favorite topic. Shipment Zero is our goal to deliver 50% of Amazon shipments with net zero carbon by 2030. And achieving Shipment Zero means that right from the fulfillment center, where an item is actually picked up, to the materials used for packaging and the mode of transportation, and that gets the package to the customer's door, are all net zero carbon, which is pretty ambitious again. And rolling out just in time for Thanksgiving, Amazon's new packaging is made available through recycled paper, where orders will typically arrive in insulated packaging, which is easy and convenient for our customers to recycle at home. And then comes the topic of frustration-free packaging, and thousands of products already qualify for a frustration-free packaging programs. And these programs incentivize the manufacturers to develop more sustainable packaging solutions for online fulfillment. On the right-hand side, you do see an icon for climate pledge-friendly products. Many of you have probably already seen this at the Amazon.com website. So items with this icon mean that we want to highlight products that meet the sustainability standards and help preserve the natural world. It's worth taking a look at those products first when you shop at Amazon.com. All right. Now let's move on to this interesting question. Is it more sustainable in the cloud when compared to on-premises data centers? The answer is yes. With the cloud, you can use what you want, whenever you want. It allows for customers to drive up high utilization. And as part of one of the researches, it was found that the same task can be completed on AWS with an 88% lower carbon footprint when compared to a US-based enterprise data center. Once again, AWS infrastructure is 3.6 times more energy efficient than an enterprise data center. And this is made possible because we control all our data centers and supply chain. We can rapidly roll out the efficiency improvements. And AWS has committed to shifting its data centers to 100% renewable energy by 2030. Talking about data centers, let's see how AWS use water more efficiently in our data centers. So we assess both the water and the energy usage to be the most efficient method. By the way, did you know that there is an increase in emissions while having to cool the enterprise on-prem data centers? Which is why AWS incorporates a technology called direct evaporative technology to cool our data centers with less water. And here's how it works. During cooler months, outside air is supplied directly to the data center without using any water. And during the hottest months of the year, outside air is cooled through an evaporative process using water. And we have optimized this cooling system to minimize water usage. And that is one more compelling reason to move to the cloud. That said, let's dive in the topic of data. So sustainability solutions are powered by data. Often customers generate the data to build sustainability solutions by themselves, say by measuring the temperature in a building. But remember that many of these solutions also require external data. For example, you might be able to cool your building more efficiently if you know the temperature outside. And this is where the initiative comes into play. AWS hosts a broad variety of data sets to make this easier, where you're provided with weather data or satellite data or even biological data. This allows customers to get started without the added burden of having to collect and store everything by themselves. And let's take an example. Landsat satellite imagery is available for free from NASA and USGS. But to use it in an application, one needs to download it, store it in the cloud, and probably also clean it and organize it so that it's more easily accessible in an application. This could be quite time consuming and quite expensive as well, because satellite data sets can be really big, running into petabytes. So by using the free Landsat 8 data sets hosted on AWS, customers can offload all that work to AWS Cloud. On the right-hand side, you have the picture for Digital Earth Africa, which makes Earth observation data free and accessible to deliver products to the African continent. That said, before we move on to the next section, it's important to talk about the climate neutral data center plan. Now, this is actually an industry commitment to proactively lead the transition to a climate neutral economy. AWS joined forces with the data center industry in Europe to create this pact in 2021. In fact, this is a good segue to the next topic, where we are trying to build sustainable architectures with AWS infrastructure. So, how do we optimize our infrastructure in cloud? As Derek alluded to earlier, many of you might have seen this similar picture as this for AWS shared responsibility model. And we have a similar one for sustainability here. There are paths where AWS is responsible and paths where the customer needs to ensure that sustainable practices are followed while building their infrastructure. The area that's green here is sustainability of the cloud, where it's basically the data centers, their servers, their electrical supply, cooling, and probably the waste management. Everything is being taken care of by AWS. It's AWS responsibility. And the blue area is sustainability in the cloud, where customers are required to optimize their AWS architectures for sustainability. So how do we optimize our AWS architectures for sustainability? At AWS, we prescribe well-architected architecture patterns to our customers through a framework called WellArchitected Framework. And just before this reinvent, we just had the first 5 pillars, which is out there in the picture, as part of this framework. But with reinvent 2021, we introduced a new pillar called as a sustainability pillar to this framework. By the way, sustainability pillar in AWS well-architected tool will be expected to arrive in 2022. And the pillar is designed to track your progress towards best practices that support a more sustainable architecture. That said, let's move on to compute. So how do we optimize cloud compute for sustainability? And as for this topic, I would highly encourage you all to tune into reinvent talks on building sustainable architectures, where they really get into the granular details. And I'm covering just a few broad topics here in this session. So talking about compute, which is basically the AWS servers for your compute, we have the following considerations. First one is on idle resources. You may want to plan if a server is really needed to be spun up, or if a workload could be run on an already existing server. Plus, maximizing utilization is the key to sustainability. Next one is on right-sizing the instances. I have personally seen cases where really big servers in terms of memory and CPU are spun up just to be safe on sizing. but unfortunately, they may not even be used up to 50%. We would want to avoid such scenarios. And then third, in AWS, you have something called as spot instances, which are typically unused instances at a point of time, available at a discounted price to our users. You may want to leverage such servers to optimize for cost. And the last one, going serverless is another option where you need not manage servers and AWS takes care of that internally. Okay, one another interesting example that was quoted in reInvent is that there are times when we schedule all jobs for our organization only at probably 12 a.m. sharp at midnight, right? It happens a lot. And in many cases, there is no rhyme or reason why we do this, except that it was just customary in the organization. But with a sustainability lens on, we would want to be mindful of the schedules and think in terms of using your AWS resources optimally under such peak loads. Speaking about compute further, so let's talk about the AWS Graviton Family. By the way, did you know that the AWS global infrastructure is built on AWS's own hardware, which includes custom purpose-built compute and storage servers? See, the advantage is that by designing our own equipment, we are able to develop hardware that does not have the excess features that draw excess energies. This in turn allows us to get the best possible performance and power efficiency gains. Graviton 2 is one such example of how we build hardware with sustainability in mind. It is an ARM-based AWS design chip. This is currently the most power-efficient processor that AWS offers to its customers. And as of reInvent, we have introduced Graviton 3 processor, newest in the Graviton processor family, which provides up to 25% better compute performance. Thousands of customers like Lyft and Formula One are running their production workloads on Graviton-based instances. Let's move on to the topic of storage. So as human beings, we would like to play it safe, and that's one of the reasons why we keep accumulating data, even when that's not needed, thereby increasing the unused duplicated data, right? It happens a lot. So varying the sustainability lens, there needs to be a shift in how we think in this space going forward. For example, let's say that there are terabytes of log data generated by some of your applications. You will need to ask yourself a few questions like, everything that is log needed? If so, for how long? Can I use some of the compression algorithms so I can use lesser cost and space? If so, which algorithm gets me the best compression ratio? So as with AWS, you can see from this picture, we provide a wide range of storage classes, which is based on data access and cost requirements. They range from standard to Glacier Deep Archive or cold storage. Use them to your advantage to build sustainable storage infrastructures. There could be cases where you may not be sure which one to pick. This is often the case, and which is why we have something called as S3 intelligent tiering, which does this classification automatically for you based on access patterns. All right, let's move on to networking now. The key principle to remember here is to reduce the data that is sent over the network. That's simple, right? Yeah, so you can use content delivery networks, so data is closer to users to build sustainable and efficient architectures. That said, that's all I had for you today, and I would strongly suggest you all to look into some of the AWS resources at the reInvent. And here are some more references where you can learn more about sustainability initiatives, the blogs, and the data available through ASDI. Thank you so much for listening, and hope this information comes to you handy while thinking about sustainability efforts in your organization.